Every time you turn on a light, charge your phone, or start your television, electricity appears to be there instantly. But here's the interesting part. The power you're using didn't begin inside your walls. It may have started miles away, passed through massive electrical equipment, traveled across transmission lines, and moved through several stages before finally reaching the device in front of you. So how does electricity actually get from a power plant all the way to your home? Let's follow the journey. It all begins at a power plant. Inside a power plant, some form of energy is converted into electricity. Depending on the type of plant, that energy might come from burning natural gas or coal, moving water, wind, sunlight, or a nuclear reaction. Many power plants work by spinning a huge turbine. The turbine is connected to a generator, and as the turbine spins, the generator converts that mechanical motion into electrical energy. Now the electricity has been created. But there's a problem. The power plant might be hundreds of miles away from the people who need that electricity. So how do you move enormous amounts of electrical energy across such a long distance? The answer is voltage. Before electricity leaves the power plant, transformers increase its voltage to extremely high levels. Why? Because higher voltage allows electricity to travel long distances more efficiently, reducing the amount of energy lost along the way. This is why you see enormous transmission towers carrying cables across fields, forests, and highways. Some of these lines operate at hundreds of thousands of volts. At this point, the electricity is moving through the high-voltage transmission network, traveling toward the area where it will eventually be used. But electricity at hundreds of thousands of volts obviously isn't something you want entering your house. So the journey continues to a substation. A substation is basically a major checkpoint in the electrical grid. Here, large transformers reduce the voltage from those extremely high transmission levels to lower levels that are better suited for regional and local distribution. From there, electricity continues through another network of power lines. These lines are smaller than the giant transmission cables you see crossing the countryside. Eventually, the electricity reaches your neighborhood. And this is where things start getting much closer to home. You might see these distribution lines running along utility poles, or you may not see them at all because they're buried underground. But the electricity is still moving toward you. Before it enters your house, it passes through another transformer. You've probably seen these mounted on utility poles. They're often gray, cylindrical containers sitting near the top of the pole. Their job is to reduce the voltage again. The electricity that has been traveling through the grid at thousands of volts needs to be converted to the lower voltage used by residential electrical systems. In a typical US home, that means supplying 120-volt circuits, with 240 volts available between the two hot legs for larger appliances. Now the electricity is finally ready to enter your home. A service cable carries the power from the utility system to your house. Before you can use that electricity, it passes through your electric meter. The meter measures how much electrical energy your home consumes. That's how your utility company knows how much electricity to bill you for. But the electricity still hasn't reached your light switch. From the meter, power enters your home's main electrical panel. You might know this as the breaker box. Think of the panel as the traffic controller for your entire house. Instead of sending all the electricity through one giant wire, the panel divides it into separate circuits. One circuit might supply the lights in part of your house. Another might power bedroom outlets. Another could supply your kitchen. And high-power appliances such as an electric oven, water heater, or air conditioner may have dedicated circuits of their own. Each circuit is protected by a circuit breaker. The breaker has an important job. If too much current flows through a circuit, the breaker can trip and shut the circuit off. This helps prevent wires from overheating and reduces the risk of electrical fires. Now the electricity begins its final journey. From the electrical panel, wires travel through the walls, ceilings, floors, and other parts of your home. Eventually, those wires reach the devices you actually interact with. Outlets allow electrical devices to connect to the home's electrical system. Plug in a lamp, and you've created a path for electricity to flow through the lamp. Plug in a phone charger, and the charger draws electrical power from that circuit. But what about a light switch? A switch is essentially a control point in the circuit. When the switch is off, the circuit is open, preventing current from flowing through the light. When you flip the switch on, the circuit is completed. Current can now flow through the lighting circuit and the light turns on. And this is why it feels instantaneous. The electrical system is already energized and ready to respond. You're not waiting for a new batch of electricity to travel all the way from the power plant every time you flip the switch. The electrical grid is continuously operating, maintaining the conditions needed to deliver power when you need it. And there's one more important part of the system that you don't normally think about: the ground. Electrical systems include grounding and other safety features designed to help control dangerous fault currents. If a fault occurs and electricity ends up somewhere it shouldn't, the grounding system can provide a safer path for that current and help protective devices disconnect the circuit. So the next time you flip a light switch, remember what's happening behind that simple action. Energy was converted into electricity at a power plant. The voltage was increased so that electricity could travel efficiently across long distances. Transmission lines carried it toward your region. Substations reduced the voltage. Distribution lines carried it through your neighborhood. A transformer reduced the voltage again. The electricity passed through your meter, entered your electrical panel, traveled through a specific circuit inside your home, and finally reached the light you're standing in front of. All of that happens as part of one enormous interconnected system. And the next time your room suddenly lights up with the flip of a switch, you'll know that the journey behind that tiny moment is anything but simple. If you enjoyed learning how everyday technology works, hit like, subscribe, and stick around for more explanations of the hidden systems we use every single day.